Good morning, everyone. This will be the reporting of Group B, and our topic is skinning in computer animation. First, I will introduce myself and our members. Our members are Mark Gerald Batariel, Galvin Maynard Proegas, Tristan Dave Caraan, Rico J. Capina, Christian George Shar, Archie Claveria, Prince Macas, Danel Umali, and Camille Valderrama. First, our topic, skinning. So what is skinning? Skinning envelopes the underlying skeleton with a super surface representation, triangle mesh, implicit surface, or a skin that conveys the appearance of the character and the forms within the underlying skeleton. So here's an example of skinning. As you can see, the picture on the middle, the object doesn't have any outer part or outer features. As you can see on the other two, there are features such as eyes, nose, and the color of the skin. So why do we need to put skinning in an object? It is to give more life on an object, to give entertainment, and to be more realistic, which can be applied in a real life situation. Just be more creative on skinning and you'll understand why it is very important and it can help you in getting good grades and such. So here's an example of skinning.
Computer facial animation. Computer facial animation is an area in computer graphics that encapsulates methods and techniques for generating and animating images of a model or a character face. Facial animation creates a neutral and resting shape for the face, then creates a number of key poses for different expressions. In example, smile, frown, pucker, mouth open, jaw open. Each shape is deformed version of the skin in a target expression. Interpolating between key shapes gives animation. Here's an example face model of creation. President Barack Obama and Abraham Lincoln.
Expression shapes. Besides scanning in the neutral pose, one needs to scan in shapes for every desired expression. Alternatively, a modeler can deform vertices by hand to create various expression shapes. Degrees of freedom. Interpolation between various poses is carried out on a node-by-node basis. Thus, the neutral shape and every expression shape is created with the same triangles and with the triangle vertices corresponding in a one-to-one fashion. This work looks better if each vertex corresponds to a fixed position on the skin surface of the character. If there are m vertices, then the ith shape is be given by x sub 1i, x sub 2i, x sub mi. Interpolation. Obtain a new shape by linearly interpolating between two key shapes.
Next topic naman pong i-discuss natin is facial motion capture. Unang-una, ano nga po ba ang facial motion capture or kaya mocap? Motion capture or mocap is a process of digital recording of people's or object movements. Motion capture technology is widely used in entertainment, notably in gaming industry and filmmaking. It is also called performance captured if it refers to design more complex patterns such as facial expression or finger movements. Yan. Kadalasan pong ginagamit ang mocap is sa mga movie po, tulad po ng mga Hollywood movie. For example po is yung Avatar, Iron Man, Avenger, yun po, ganun po. Instead of animating AH, one can compute AH via mocap. Given a mocap frame, compute AH such that the resulting shape matches the mocap data as close as possible. Ayan. Increasing the number of shapes allow for the actor's performance to be more closely matches. An insufficient number of shapes can cause details in the actor's performance to be lost. Yun, sa dami, kung gaano po kadami yung shape na number of shape na maano po dun sa mockup natin, ganun po mas close talaga yung galaw nung pinagkokopyahan po ng galaw po nila. Ayun po. And finally, H can be remapped to another creature as long as the column vectors of the shape or displacement matrix shape corresponding meanings from the actor shape matrix to the creature shape matrix. And ito po ang image po na example kung ano nga po ba yung mockup para po maging familiar po sa inyo.
A different approach. A similar process could be carried out for the body. For example, is create a shape matrix and interpolate. But the shape of the body is highly dependent on the angles of joints. So one can bootstrap the interpolation weights from the joint angles. The joint angles do miss the shape information such as whether a muscle is being intentionally flexed. Dito daw ay nakadepende daw yung body shape mo sa angles ng joints. For example is nag-flex ka ng muscle mo. Hindi ba magbabago yung shape ng shoulder. Many parts of the body are relatively disjoint from each other. So we expect the displacement of matrix to be sparse, but the shape matrix is not sparse. Because of this consideration, we approach skinning the body in a highly different manner, while noting that it still highly depends on shapes and interpolation.
For the summary, decompose the entire skin for the whole character into smaller pieces and place a portion of the skin into the object space of each bone. Then, the pieces may overlap. Multiple bones may share the same skin vertices, given a set of joint parameters theta. Let time I theta represent the transformation that moves bone I from its object space to world space, as the joint parameter change and the bones may in world space. Calculate where the skin vertices are located in world space as well as using time I theta. Skin vertices which exist in the object space of multiple bones require some sort of interpolation or averaging. So meaning, if you have a multiple skin that may vary, you may use interpolation or averaging.
Rigid skinning. Each skin vertex is assigned to exactly one bone. For example, the skin for the upper arm would be assigned to a different bone than the skin for the forearm. Use the transform of the associated bone to position each vertex of the skin in word space. Ano nga ba pag sinabi nating rigid or rigging? Rigging is a technique used in a skeletal animation for representing a 3D character model using a series of interconnected digital bones. Specifically, rigging refers to the process of creating the bone structure of a 3D model. This bone structure is used to manipulate the 3D model like a puppet for animation. Yan, ang rigging is the most common in animated characters for games and movies. Ang rigging ay paglalagay ng mga bone sa 3D object or sa 3D character or sa meshes. Ano ba pag sinabing skinning? Skinning is the process of binding the actual 3D mesh to the joint setup you created. This means that the joints you set up will have influence on the vertices of your model and move them accordingly. Yun nga, pag sinabing skinning, ito yung pagbabind ng bone sa 3D object mo. Consider a vertex J with position vertex J in the object space of the eye bone with transformation tie. Then the world space position of vertex J is given by vertex J plus 1 equals to transformation vertex J. As the skeleton moves, tie change and the vertex position of the skin change as well.
Unwanted discontinuities form along the boundaries where neighboring skin vertices are assigned to different bones. Ang skinning ay tinatawag ding vertex blending. Example naman dito ay yung arm. Ang pinaka-example dito ay yung sa curve ng elbow. Sa bawat curve ng elbow ay may tinatawag na weight. Ang position ng rigid ay nakaka-apekto sa vertex. Kasi sa bawat paggalaw ng rigid ay paggalaw din ng vertex.
Next po ay weights. Weights for a vertex should be sparse. Non-zero weights should be localized to nearby bones. Ayun nga po. Kaya po siya should be sparse kasi po para po pag nag-ano po kunyari po yung elbow joint is nagpalit po ng angle, ano po, yung skin po nung nakaano sa joint na yon is sa bone na yon ay hindi po siya magde-deform. The next weight is sparse weights allow for fast evaluation, typically at most for non-zero weights per vertex. Ayun po, parang ang ginagawa po niya is mas pinapabilis po niya yung process ganun ng sparse weights. Kasi nga po, walang masyado nagde-deform na mga, kunyari po skin ganun. Weights should be smooth to avoid discontinuities, often chosen with a smooth fold-up based on distance to a particular bone. And next is weights should be independent of mesh resolution, so that subdividing the mesh doesn't require computing weights. Kaya po, inano na independent yung weight is, para po pag mag-compute po nung pag-subdivide ng mesh is, mas mabilis at hindi po mako-consume din yung time ng pag sumama po yung weights is, baka po mag-recompute din siya kasabay nung sa pagre-recompute po nung sa pag-subdivide ng mesh. And last is constrain the weights to be convex to avoid undesired scaling and extrapolation artifacts. Ayun po, sa pag-constraint ng weight is iiwasan po natin yung undesired scaling, like baka po biglang ma-resize natin, ganon, etc.
Next is specifying weights. Manual approach. Hand-tune weights in order to obtain the best look. Hand-tune weights or manual tuning of the weights for the bones para mas makuha natin yung best look for our 3D model. Next is intractable to individually modify the weights for each vertex in large mesh. So, hindi daw madali na ma-modify yung mga weights for each vertex kapag malaki yung mesh. Next is various painting tools facilitate weight specification. So, isang way daw para ma-figure out natin yung weight of our 3D model is to use painting tools or by painting it on its skin. So next is automatic approach. Use an algorithm to calculate weights for each vertex and all its associated bones. Example given is based on the distance metric for vertices to bones. So sa part na 'to, pumapasok na yung calculation ng weights by the use of algorithms. Next is automatically generated weights are often additionally modified by an artist for higher visual fidelity. So, yung mga automatically generated weights daw is kadalasang binabago ng mga artist para mas makuha nila yung best look for their 3D model. So next is specifying weights. Pinocchio. So in Pinocchio, systems are they use systems for automatically reading and animating 3D characters. Solves a Poisson equation
for each bone with appropriate boundary condition to obtain smoothly varying weights. So yung Poisson equation, it is a elliptic partial differential equation of broad utility and theoretical physics. So yun yung equation for the potential field that is caused by a mass density distribution. So it is can be used to rig and skin your own characters or 3D models. So it is available from MIT. This is the link.